Steelmaking. The process basically starts with the production of iron, of which the raw materials are iron ore, coal, and limestone. The iron ore is stored according to origin. Then the various sorts are reclaimed and piled in layers on a fines bedding. Before being transported to the next step in the process, the layers are mixed in the rotating drum of a reclaimer to make an optimal blend. Via a transporter rolling over a furnace, the other raw material, the coal, ground to powder, is blown into the furnace. At 1100 degrees centigrade, the coal is now converted into metallurgical coke, consisting of pure carbon with minor pollutions. Removed from the furnace, the metallurgic coke is guided through a quenching station and will, after cooling, be screened into large-size coke, termed lump coke, later on to be used in the blast furnace, and small coke breeze, to be used in the sintering process. Iron ore, coke breeze, and also limestone are now carefully dispensed and blended. This blend is spread on a strand, which slowly moves under a combustion hood. The sintering process. The combustion zone moves downwards through the blend. The high temperature sinters the ground iron ore into a porous mass. As soon as the blend is completely burnt through, it is cooled, crushed, and screened, while the fines are returned to the sintering process. The remaining product is the sinter, the basic component for the next step. The blast furnace operation. Sinter, lump coke, and limestone are, via conveyor belts or skips, transported to the top of the blast furnace. Iron ore is principally a compound of iron and oxygen. Iron is produced by the extraction of oxygen using coke. This reaction is endothermic. To sustain the reaction, extra coke is injected together with hot air. The air is preheated to around 1250 degrees centigrade in hot blast stoves and blown into the furnace through toyers, which are equally distributed around the furnace. Moving downwards, the sinter, coke, and limestone are converted into liquid iron and slag. To save the use of the more expensive metallurgic coke, sometimes pulverized coal or oil is injected. By computers, the process operating parameters are kept under close control. The iron, termed pig iron, is collected at the bottom of the blast furnace and tapped into a torpedo later. It's here that the real steelmaking process starts. Beginning with a desulfurization process by injecting lime powder. To avoid loss of ductility at high temperature, a sulfur reduction to values lower than 0.010% is necessary. Now the liquid pig iron is transported to the steel plant. Steelmaking can be carried out in several processes. Nowadays, only the oxy-steel and electric arc processes are relevant. In the oxygen steelmaking process, the liquid pig iron is transferred into another ladle. The temperature is measured, samples are sent to the laboratory, and the floating slag is removed. The liquid pig iron is now poured into a converter. Subsequently, scrap is added. This is to control the temperature increase due to oxidation of impurities, mainly carbon and silicon. By means of a water-cooled lance, pure oxygen is blown into the bath. The impurities are oxidized to slag, floating on the bath surface. Finally, a bath temperature of 1650 degrees centigrade is obtained. At the end of the oxidation process, samples are taken for chemical analyses. Within 5 minutes, the results are presented on a screen in the steel plant. From the analyses, also the amounts of alloying elements and reagents for desulfurization and deoxidation are determined. Alloying elements to ensure a steel composition related to the final properties and use of the steel. By using aluminium, the steel is deoxidized. The steel is killed. The aluminium associates with oxygen, improving ductility. These elements will be added during tapping of the steel from the converter into this huge ladle. The ladle is placed under the converter. Steel and slag are poured out of the converter separately. Tapping, first the steel. After that, the slag. The liquid steel is then stirred using an inert gas, argon. This to ensure composition and temperature to be homogeneous throughout the ladle. In addition, the gas bubbles float out impurities, which are absorbed into the slag. After refining, the ladle, now containing about 300 tons of liquid steel, is taken either to a continuous casting machine or, like here, emptied into ingot molds.